Okay, everybody, final video for lesson 10.1. It's going to be a kite. This is number 17 in the homework. Okay, and this is a really good problem. I could imagine this being somewhat challenging for you guys, for any students. But there's a simple trick to this, and I'll just let the cat out of the bag right now. The simple trick here is 30, 60, 90 triangles. Okay, let's take a look. You're given that it's a kite. And they only give you a few dimensions. They give you that this side here is 14. I didn't put the units on, just kept them out of the clutter. Inches, I think. 14, this part of that diagonal is 7 root 3. And then this larger side here is 14 root 3. Okay, so there are a couple ways you could go about working through this, and different approaches you could take. There are a lot of ways you could work through this. You could isolate triangles, work out bases and heights, and figure things out and break it down into steps. You could do all that. The most, I think, efficient way to do that is to kind of remember that 30, 60, 90 triangles can be your friend. And you have 30, 60, 90 triangles going on here. And that's what we want you to see. That's why this problem is designed the way it is. It wants you to see that. Take a look, okay? Bear with me here, kind of follow what I trace out. Take a look at this triangle right here. Look specifically at the dimensions you're given. You have a hypotenuse of that triangle is 14, and the longer leg is 7 root 3. Now, ask yourself, what is that shorter leg right here where my fingers are? What has that got to be? Now, you could use the Pythagorean theorem to figure that out. But I'm telling you, you're going to get 7. Why are you going to get 7? That's the only possible number that can explain that kind of relationship where you have a hypotenuse that's twice the short side, and where the short side to long side is just times root 3, right? X, 2x, x root 3, right? Or x root 3, 2x. That's your 30, 60, 90 relationship. In other words, that's 30 degrees up there, and that's 60 degrees there. Even though it doesn't say that, it has to be. That's the truth, okay? Again, the Pythagorean theorem can verify all that, but you don't even need to do that. You should just recognize, okay? So that's 7. All right, so let's kind of back up a second. What are we looking for here? So recall that the area formula is 1/2 d1 times d2. So just like a rhombus, we need d1 and d2. What is d1? What is d2? Well, if we call this vertical diagonal here, this segment, d1, we know that that's got to be 7 root 3 and another 7 root 3. That's got to be 14 root 3, right? So we know one of the diagonals is 14 root 3. Makes sense, right? If that's 7 root 3, this is 7 root 3. Okay, so that's 14 root 3. Okay, well, we need the other diagonal, and we've got that this piece of it is 7. So we need the remaining portion of the segment. Okay, we need this piece. All right, now again, 30, 60, 90 triangles are in play here. Consider this right triangle right here, okay? Again, look clearly at the relationships. This short leg is 7 root 3. The hypotenuse is double that, 14 root 3. What's the longer leg gonna be here? Well, take the short leg, 7 root 3. Hope you can see all that. Hope my font's not too small there. And multiply it by what? Root 3 again, which becomes what? 7 root 3 times root 3 is 7 times 3 is 21. You get it? That piece is 21. So this piece is 7. This segment is 7. This segment is 21. So what is the entire diagonal to? It is 28. Okay? And I'll leave it basically to you from there to plug those values in to the formula, 1/2 times 14 root 3 times 28, and I believe you get, is it 196? Just checking, yeah. You get 196 root 3, and then your units are, I think, inches squared, okay? And that's it. Hope that helps. Take care.